All right. What now? Actually, um, what would one be expected to do with this material? Let's say, for example, you're looking at pressure. You're always known that this is pounds per square inches or psi, or this is a force over a length squared, or a force L to the minus 2. Now, in the lecture soon, we're going to talk about density. This is just it is a mass per unit volume, which is nothing more than a mass per length to the third. Will be introduced later to viscosity. If you look at it, it's a length squared times to the minus 1. Now, let's say someone were to build a table. Let me add one more thing. For example, let's look at power. And we'll just call that PW. And its units are usually force, length, time to the minus 1. Foot-pounds per second or something like that. Now let's say someone built the table. Let's build a little table over here. For quantity, MLT, FLT. And let's say someone put a value of P rho mu in there. And they said, I want you to fill out this and this. And then they put, say, PW times mu in here. And then pressure over density. And they said, fill this out. Well, how would we do that? First, we have to recognize these are the representation. So here's our representation. We're looking at not the system, but now representation. We want a FLT representation of it or an MLT, not both. Now, let's look at, for say, this one. Pressure over density would be nothing more than, and here's our values that we're tying to our symbols. And our pressure would be FL minus 2 over, here's our density, ML minus 3, to be nothing more than F, M minus 1, and then L. Since this is a minus 2, and if this moves to the top, it'll be plus 2, then plus 3, then we ended up with just that. Problem is this is a representation that falls neither under MLT or FLT. So, how do we convert? This was the whole point of the discussion in units when we were looking at the unit changers. This is the key. F is equal to mass times length time to the minus 2. So, F is equal to MA is a unit exchanger. Mass is equal to, we've got an F. Move this over here, length to the minus 1. Move the time over, T squared. So, this is how you exchange one unit system to the other. Of course, you have a force on one side exchanging. You have length and time carried along for the ride. But this is how, if you had a mass and you wanted a force, this is the equation you, if you had a force, if you wanted a mass, this is the equation you use. Taking this, let's say the first one is I want to get rid of the force. So I would have mass, length, time to the minus 2 would be the force that got put there. And then you'd end up with a mass minus 1 and a length. So what you'd end up with is mass, this and this, it'd be gone. You'd end up with a length squared, have a length here and a length there, time to the minus 2. Now, let's take a look what happens if we're going to X out this. So you look at this. We're going to take this down now, and we're going to put in force times, now I'm looking to get rid of the mass, so I'll say F L minus 1 T squared. This is all brought up to the minus 1, and then L to the 1 power. So this equation was brought down. This was brought down in order to get rid of the mass out of here. And so what we end up with is force. Now the minus 1 moves inside here. Minus 1, length plus 1, time minus 2, and then a length plus 1. What happens is this knocks that out. These two get added together, and you get this answer. Notice they're the same because there is an absence of either a mass or a force in the final equation. So it really doesn't matter. So if someone were to give you this table, they would expect to see the answer to look something like this. However, if someone were to put in, say, power times viscosity, well, let's take a look. Power times viscosity, the units on the power, we're going to just grab them up here. F L T to the minus 1. And on the viscosity, going to have L to 2 T minus 1. L2 T to the minus 1. Which means my final units will be F. There's now 3 L's, and there's now 2 T's. So immediately you could put this back in the equation if you wanted to. You could just grab it, go back up to wherever you we were looking at this, and shrink it down, put it in there. So there's your answer on that one. Now the key is that fits under the FLT because of the existence of the F here. However, that doesn't take care of the other part of the system. Now the next key is, how do you replace that with a mass? That's where you reach and grab this, put it in here, mass, length, time to the minus 2, we'll grab from up here, times length to the third, time to the minus 2. Okay, so you end up with mass. There are 4 of those now, and there are 4 of these. So reach up here, this is your answer, grab it, run up to the top, right, it got moved to the side, and that got put right there. So again, what you notice is a mass existed here and a force existed here. Notice the trade out. You change the exponents on the length and time for doing this. So this is what you should be able to do with this, is to be able to move quantities into different representations. It's that simple. And if you were given quantities and their units on the side, no matter what the quantities were, I mean, it didn't matter that you understood them. There could be something like a pi 1, and it could have a bunch of units here. Then there could be, say, a pi 2. There could be a bunch of units here. And then someone may ask you, put a table together, and say that they wanted pi 1 and pi 2, MLT system, FLT system. The significance of what pi 1 times pi 2 is in material. The ability to move into the different coordinate systems, or sorry, coordinate representations, is the key here. So if you're able to do that, that's what you should, that would give you a good handle on the use of units. Okay, with all that being said, well, how would you practice for something like that? Here's a good way. Create your own table. And say, just start listing some values. Pressure times viscosity. How about just anything? It doesn't even matter. How about torque? Just call it TO for torque times viscosity times pressure. Rho velocity times mu. Just create as many as you want and go through the exercise of filling out the table. And as you fill out each of these tables, just practice and basically come back, visit your neighbor, and you guys create the two tables and talk to each other about how you did it and compare notes when you get done. It's that simple.